Good evening, guys. Hope you are doing well. So, in our last session, we discussed about firewall policies, right? Am I audible?
Yes.
Okay. So, in our last session, we discussed about firewall policies and net. So, let's go through it and then we will start our practical, right? So, what is a firewall policy? A firewall policy is a set of rules that determines what traffic is allowed to pass through the firewall, right? It allows and denies the traffic, right? Firewalls act as a barrier between a trusted network and the untrusted network so that we can protect our security devices from untrusted access, right? You can say our LAN or our data center. So there are some key points that we should discuss about firewall policies. Rules. Firewall policies consist of rules that defines the criteria for allowing or blocking traffic. Each rule typically includes information such as source and destination IP address, ports, protocols, and actions like allow or block. For example, if I have to visit Instagram.com and I am a marketing person, so what the rule will be like in Fortinet firewall is source will be marketing firewall's IP address, destination will be Instagram service, okay, WAN port, right? And the traffic will be allowed, right? Guys, be active, please. So, the second key point is implicit deny. Firewalls typically follow a deny approach, meaning that unless there is a rule explicitly allowing certain traffic, all traffic is blocked by default. This helps ensure that only unauthorized traffic can enter or leave the network. For example, there are two, three, three rules that we have made in the firewall, right? But but we can say that if you want to access Instagram.com, right? But here in the rule, there is no definition of Instagram. It will check all our firewalls from top to bottom. And in the end, there is an implicit denial. So when it doesn't match with any of the rules we have mentioned in the firewall, then the traffic will be implicitly denied, right? So order of rules. Here in firewall policy, or you can take any access list, right? It follows top-down manner where the rules are checked against each rule sequentially until a matching rule is found, right? One, yeah, guys, sorry for the interruption. So, order of rules we were talking about, right? Firewall's rules are processed in top-down manner. As we can see that all the rules that we must have mentioned on the firewall are gone from top-down manner, right? When a packet enters the firewall, it is checked against each rule sequentially until a matching rule is found. Once a match is found, the corresponding action is taken and further processing stops, right? So once the rule match with a certain rule that we have mentioned, then the process will stop and it will allow or deny as per the policy. So here let's discuss about stateful inspection. Many modern firewalls use stateful inspection to track the state of active connections. This allows the firewall to make more informed decisions based on the content of the traffic firewall, such as allowing response packets for outgoing connections. Right? Here, the inspection, what it does is it tracks the session of active connections. So it will make firewalls more easily to context to make decisions based on the context of the traffic flow. Right? So let's discuss about logging and monitoring. Firewall policies often include logging capabilities to record information about the traffic that is allowed or blocked. Monitoring these logs can also help administrator identify potential security incidents or troubleshoot network issues. So, when we make a rule, we can see the logs of that rule. Based on that rule, that what are the things happening, who is getting access or who is getting denied by that rule, right? Let's get to the next part, application awareness. Some advanced firewalls offer application aware filtering, which can inspect traffic at the application layer to enforce policies based on specific applications or services. Here, the firewall also works on application layer and it can enforce policies based on some applications or services, right? Regular review. It's important to regularly review and update firewall policies to ensure they align with the organization's security requirement and network changes. So, as we all know that we must update frequently our policies and also we have to align with the security requirements and network changes, right? Any doubt, guys? Clear? Anyone?
So far, we have understood everything. Oh, I understood everything on my own side. From my side, I have no questions. Everything
Okay,
is
thank you.
understood.
Thank you. Thank you.
Yeah.
Okay, so let's move forward. Let's recall our last session's net policy, right? So, what is a net? Can anyone? What is a net?
Network address translation.
Okay, what it does?
It converts IP addresses into the host name.
No, not that.
It's not that. So it's convert, it will be mapping our private IP with the public IP.
Yes, right, right, right. Anyone else?
Used to hide internal IP.
Your voice is not clear, Francis.
It can also translate public IP addresses into local IP addresses.
Yes, right. Look, it's not local, it's public to private and private to public, right?
Yeah.
Okay. So, what is a NAT? Definition. Network address translation is a process in which one or more local IP addresses is translated into one or more global IP addresses and vice versa in order to provide internet access to the local host, right? Inside local address. So, what is an inside local address? An IP address that is assigned to a host on the local inside network. The address is probably not an IP address assigned by the service provider. That is, they are private IP addresses. This is the inside host seen from the internet from the inside network, right? So, what happens in network address translation is that one or more private IPs are converted to public IPs to access the public internet so that we can safeguard our systems, our private IP addresses from unknown websites, right? There are too many trackers on websites that can cause harm to our system, internal system, right? As we are in our organization, we have to protect our private IP addresses. So there are basically three types of NAT: static NAT, dynamic NAT, and port address translation. PAT, right? Static NAT. In this, a single unregistered IP address is mapped with a legally registered IP address. That is one-to-one mapping between local and global addresses. This is generally used for web hosting. So in static NAT, what happens here is one IP address, which is private, is mapped to one IP address, which is public. But it is very expensive, as for every single device in our network, we have to buy a separate IP address, which is not which is not a great which is not a great thing, right? It will cost us too much. So let's talk about dynamic NAT. In this type of NAT, an unregistered IP address is translated into a registered public IP address from a pool of public IP addresses. Here, a pool of public IP addresses is made, and a person once a person from private internet has to visit public network, what the firewall will do is he will give him a public IP address from the pool of public IP address, right? If the IP address of the pool is not free, then the packet will be dropped, as only a fixed number of private IP addresses can be translated to public IP addresses. Okay? Port address translation, which is also called as PAT. This is also known as NAT overload. In this, many local IP addresses can be translated to a single registered IP addresses, which is basically means many to one. Port numbers are used to distinguish the traffic, that is, which traffic belongs to which IP address. This is frequently used as it is cost effective, as thousands of users can be connected to the internet by using only one real global public IP address, right? So, SourceNet. SourceNet, as name suggests, is a technique that translates source IP addresses generally when connecting from private IP address to public IP address. It maps source client IP address in a request to a translation defined on big IP devices. It is almost common form of NAT that is used when internal host needs to initiate session to an external host or public host. So what SourceNet in SourceNet, what we can do is we can use the outgoing interface IP address as our NAT translation for translating our IP address. In destination network address translation, DNet, as name suggests, is a technique that translates destination IP addresses generally when connecting from public IP address to private IP address. It generally used to redirect packets destined for specific IP address or specific port or IP address on one host simply to a different address, mostly on differently host, right? So here what happens is destination host IP address is used to to translate it to NAT. Okay. So advantages of NAT. NAT conserves legally registered IP addresses. It provides privacy as the device IP address sending and receiving the traffic will be hidden. Eliminates address renumbering with the network evolves. So disadvantages of network address translation are translation results in switching path delays. Certain applications will not function while NAT is enabled. Complicate tunneling protocols such as IPsec. Also, the router, being a network layer device, should not tamper with port numbers, but it has to do so because of NAT, right? Any questions, guys? Any questions?
No.
No, from my
Okay.
side.
Okay. So let's start with our practical for policies. Okay. Give me a minute to start the server. Okay, guys. So over here, as you can see, I've taken a FortiGate firewall, a Windows machine, and a net, a basic topology to understand how we can. Let's take a look at our policy, right? FortiGate policies. Let's start the device. So what I'm going to do is I'm going to keep our WAN in 192, our LAN in 192.168.1.0.24 network. Okay, will be our LAN. Our network in 10.1.23.0. Okay, so let's configure our FortiGate firewall. Admin. Let's keep our password. Okay, let's take GUI access with the help of port 2. System interface. Edit port 1. Let's take access via port 1, which is our LAN network, right? Step static 1.1/24 set IP. Okay, set allow access. Okay, we have given our IP address. Okay, let's go to our Windows machine. Let's specify the IP address over here also. Properties. Can give 90 or we can say 70. Okay, let's check on an access. Let's wait for the PC to connect to the internet. Let's take access of our GUI, Fortinet GUI, right? Wait a minute, guys.
Sir, I think you didn't specify the gateway, that's why it's not reachable.
Okay. In the Fortinet, right?
Yes, in the Windows setting.
Yeah, mentioned over there.
Okay.
That's okay.
Only the gateway when you are on the same subnet.
Yes.
Can you open one more time network setting?
Yes, yes. Here you can see I've given the default gateway, right?
Full gateway, by the way, not required because it
Yes,
is
I know,
set.
but
Yeah.
Yeah,
it was
it's
not
not
connecting. That's
required.
why
We
I
are
gave.
on the same subnet.
1.70. Can you 1.1? Can you check the interface status? It is. Can you try to ping from the device towards PC?
Oh, 10 to field.
Can you open the diagram once?
Yes.
It is okay. It is enabled.
Range.
The interface is enabled, right? It is not in
Yes.
such.
Yes,
Very
it is
strange.
enabled. As we have given IP address on port number 1, right? Firewall.
Yeah.
And network interface is by default on.
Mm-hmm.
It
Oh,
should get connected. I think there is some issue with the Windows image. Why it is not taking the access? Let's try DHCP. Let's see what it's doing. Mhm. It is not detecting the Ethernet port, I think. Let's wipe and restart it.
Your Wi-Fi subnet also same, right?
Yes. I think I will be able to access the board here.
Can you use another browser?
Yes. No, it's not about the browser though. We are using it on Windows machine. That's why.
No, you for connecting from directly from your PC, you need to connect the cloud management cloud.
Yes, yes. Right. We have to take access to the net, right?
Sorry.
No, no. Not.
Connecting directly from
What?
10.1.
Which one?
If you are connecting directly from your PC to the 10.1, right?
Let me check. Another thing. What we can do is
Network. We need to add network, not node.
yes, yes, yes.
One.
You can refresh the page. Uh, uh,
Yes.
you can keep this port 3 on 192.subnet.
Okay.
And port 1 LAN, you can choose different subnet. On port this 3, this can you can put in 192 subnet, or you can make it DSCP. Anything will work.
Okay. I will. It will be okay, right? 200.
Yeah, you change to 192 dot series.
Okay. I will change it to 192. Okay. Right. I've changed it.
Now I think you can access it from your PC.
Yes, sir. Yes. There's another thing opening.
No. What is your this 1.1, right?
What?
On port
Gateway.
3. port 3, what is the port 3 address?
Port 3 address is 200, 192.168.1.200. Here.
You have any other server on the same network?
No,
Other you
no.
can check.
I think there is some cross connection with it. Let's change the IP.
Can you try to ping that IP first?
Yes. Let's do one thing. I will start my net topology. I will show you the policy over there. Okay. So I will show you over here. It should work. Okay. Think there is some issue with the Windows machine. So we'll look our policy into this topology. Okay. Let's first ping from R1 to R2. Make a cross connection between LAN to WAN. Okay. Let's first go with our firewall. Password is blank. Password set at 2123. Okay. Config system interface. Port 1. Set mode static. At IP 192.168.1.201. Insert 3/24. Okay. Set allow access. Okay. So let's try to access this from different browser. it should get connected, right?
Command was wrong. Execute, get right.
Yes.
No, not in this way. This is from T.
Yes, yes. Yes, it is pinging to my gateway. It is working. Yes, now it works. Okay. Sorry for the trouble. Let's go to network interfaces. So as you can see, for port 1, which is we are accessing our Fortinet Firewall's GUI, right? So here, this is our LAN and this is our WAN. Okay. So just to understand the basic policy, we will set a rule so that we can get access to WAN from LAN, right? Wait a minute, I will be back. Okay, guys. So this is our LAN and this is our WAN. Okay. So let's go to our firewall. Port 2 is our LAN, right? Add it. LAN. Okay. Twenty-four. Enable ping. Okay. So for port 3 is a unwanted port, right? Your type is 4.2.2.1. Allow ping. Okay. So here we have set our interface IP addresses for FortiGate. Here we will do the configuration of the routers. Enable config terminal. So here we'll set our IP address interface E0 IP address 4.2.2.10 255.255.255.0 no ship exit. We'll give an interface loopback 1 8.8.8.8 255.255.255.255. Okay, IP address. Let's go with our R1 en config terminal interface E0 IP address 10.1.1.10 255.255.255.0 no shut loopback interface loopback push let exit, then make an interface loopback to IP address 1.1.1.1 255 255 oh shit. Okay, so let's go to our firewall, and in firewall we will go to policy and objects. Over here we will create a firewall policy, right? As you can see over here, there is a by default policy, right? Implicit deny. So here all sources, all destination, always, services all, action will be denied. So anyone trying to connect to anything or trying to ping anything, the action will be denied, right? They will not form a communication between them. Okay, so let's create a static route first so that we can create a policy after that. to communicate between both of them. Okay. So here we will give a gateway of 4.4.4.2.2.1. Okay. We'll give WAN. Sorry. 4.2.2.10. It will be WAN. Okay. So let's make a policy. Firewall policy. Create new. So here, as you can see, that we have to name what our policy is, right? So here we can say LAN to MAN. WAN. Here we have to select the incoming interface. So here the incoming interface will be port 2, right? Which is basically our LAN port. And our outgoing interface is WAN port, which is port 3. The source will be all. But here we have to give permission so that LAN can go towards WAN. So what we can create over here is we can also create an object over here of our LAN devices so that we can give access only to our LAN devices to visit WAN devices, right? Here there are some addresses such as fabric device, gmail.com, Microsoft, etc. Here are users also, guest user, or you can create a user and you can enable access for it, right? Here you can also see internet services such as Google, Gmail, Cyfing, Microsoft WNS, etc. You can select all or you can select only one of them, right? So let's create one address for our LAN network, which is basically called as object group, policy object. Here we will name it as LAN. Our subnet will be 10.1.1.0/24. Okay. So we will select source over here as our LAN. Destination will be all. Services will be all. Okay. We will select the action accept. For now, we will keep it off, right? Okay. So as you can see, we have created our first policy on our firewall, right? We will select it and we will clear it all. Okay. Let's give default route over here on our routers, right? IP route 0.0.0.0.0 okay. And on router 2, it will be
Add the command.
4 dot. Yes,
No, add the command, then it the IP address.
yes, okay. IP route. Four dot 2.2.1. Okay. So let's try pinging. to our WAN side, right? Ping 4.2, sorry, ping 8.8.8.8. So as you can see, we are able to ping it successfully, right? Let's see if it is denied. Okay. Let's try pinging from R1. As you can see, we are unable to ping, right? Actually, last time I pinged from the same router. So let's check it again. Okay. I pinged from the wrong router, which was R2. It has its own loopback, right? Let's select accept, apply. Let's go to R1. Stick ping. So as you can see, we are unable to ping, right? Okay. Anyone have any questions about the policy?
I have a question with we have problems with the first ping, and I wanted to see how the changes you did for us to be able to ping the network and it went successful. The first ping we did was not successful when we were doing the configuration, so I did not follow up the changes you did for us to have a successful ping.
Okay. So you want me to try it again?
Yes.
Yes?
Yeah. Yes.
Yes, I will deny it again, okay? I will deny it over here, right? I'm going to R1, which is our LAN, right? I'm again doing the ping, which is 8.8.8.8. Here you can see we are unable to ping, right? Right?
Can you go to logs and reports once?
Yes, I will show you that too. So after we right click, we can find our show matching logs over here. Okay. As we have denied it, let's see. Let's enable it. Now it will show us the logs. Okay. Let's allow. Let's ping. Okay. Now let's check the logs. It should work, right?
Just cancel the policy, the check, and check all the logs.
Okay. Yes, that is showing over here now. It is taking time to refresh. Okay,
Okay.
as you can see, we pinged it, right? So let us see what is flow-based firewalls, and after that we can continue with our net practical. Okay, flow-based and proxy-based. Okay, so let's talk about proxy firewall. In a proxy-based approach, the security devices act as an intermediary between the client and the server. It establishes separate connections with both the client and the server, right? When a client initiates a connection, the security device establishes a connection with the client, inspects the traffic, and then establishes a separate connection with the server to forward the traffic. The security device terminates and re-establishes connections for each session, which allows for deep packet inspection and content filtering. So, in proxy firewall, basically what happens is when a connection is initiated, the security device makes another connection to check, and also which allows it to take deep packet inspection, which is also a time consuming thing, right? Proxy based systems are effective for protocol level inspection, content filtering, application layer security controls. However, proxy based systems can introduce latency due to the additional connection setup and processing required for each session. In flow-based firewall, In a flow-based firewall approach, the security device inspects and processes traffic based on flow information, such as source and destination IP addresses, ports, and protocols. Flow-based system analyzes traffic based on predefined rules and policies without terminating and re-establishing connections for each other. So, in flow-based firewalls, it doesn't create it doesn't create new networks or connect new sessions for each session, right? What it does is it analyzes the traffic based on predefined rules and policies. Flow-based inspection is typically faster than proxy-based inspection because it does not involve the overhead of establishing separate connection for each session. Flow-based systems are well suited for high-speed networks where performance is a critical factor. However, flow-based systems may not provide the same level of detailed inspection and control as proxy systems, especially for application layer protocol. So, as we can see over here, that flow-based firewalls are fast, but they are not that much safe as they don't do the deep packet inspection thing, right? Whereas in our application, whereas in our proxy-based deep inspection is done for every single packet, right? So, which is the most used proxy? Which is the most used infrastructure in nowadays? Proxy or poly, or you can say flow-based.
So them are using flow-based nowadays.
Wait a minute, guys. Guys, let's continue with our net practical. Okay. If any questions, ask me. Right.
So how we are selecting the method proxy or flow base?
Hmm? Can you
It's
come again?
No, it's
Yes, how
depends
do
on
we selecting the which firewall mode we need to select, either it is proxy mode or flow base?
Hmm.
I think it depends on
Selecting
requirement, because if you have a secure
it will
server,
depend on our infrastructure, right? Our
yeah,
organization. So basically, if we have a small infrastructure, we can go with proxy firewalls, which are deep, which have the capabilities of deep inspection, so that we can save from our malware. But if we have a larger, we can also go through flow based, as we already have firewalls to secure our connections, and also we have antiviruses and all that stuff to protect our LAN network, right?
If I understood well, the question is how do we configure proxy firewall and flow-based firewall? I think that's what we wanted to ask precisely.
I didn't get you. Can you repeat it again?
I think the question was how do we configure proxy firewall and flow firewall?
Sorry, but I didn't know about it.
We just talked about proxy firewall and flow-based
Yes,
firewall. So
yes,
how can we configure them on the firewall?
yes. There is an option over here. You can see. Let me show you. When we go to policy, firewall policy, right? Here, you can see the inspection mode, right? For flow
It's
based,
okay.
okay,
We
okay.
just need to choose.
Yes, we just need to choose.
Okay, thank you
Okay,
very much.
okay, okay. Let's start with our network address translation then, right? So what we will do over here is we will do a NAT over here, and we will use port 3's outgoing interface IP address to translate the IP address of local area, right? We will give it as a NAT. We are creating a new firewall policy for NAT. Okay. So the incoming interface will be our LAN, and outgoing interface will be our WAN. Source will be our LAN. We can select over here, and destination will be all, or we can select LAN to be specific. Okay. We can create over here for our addresses. Here we can say it WAN. We can give the IP address 2.2.2.0/24. Interface will be WAN. Okay. Here we can select our WAN port group. Services will be all. We will select proxy based or flow based. Okay. So here, as you can see, our NAT policy is on over here. So we are using outgoing interface, or we can also use our dynamic pool, right? So what we are doing over here is we will use outgoing interface as our policy for NAT. Okay. So let's go to our routers. And let's see. Okay. I will do the debug ICMP command over here. Okay. Now, what we will do is, first of all, change it to all, and I'm also keeping NAT to disabled. Okay. Let's ping 8.8.8.8 here. As you can see, the destination IP address over here is same as the IP address of our port, right? R1. Right, guys? You can see over here the source, the destination, right? Which is reversed. Okay. Here. Now what we will do is we will enable our NAT over here. And now we will ping. Okay. So wait a minute.
I think you need to make
Yes.
the net policy of the LAN means because it's sitting on the first policy itself. It doesn't go to second.
Okay. Yes, yes.
You need to scroll that unneeded.
Okay. Let's try it now. It's still the same. Wait a minute. Let me check.
Make a continuous ping and see on the logs and reports. You can see.
Yes. Okay.
You repeat. RE.
Okay.
No. Ping.
On the
Ping.
end.
Last one is repeat. Go to a global config mode.
Like 1 million.
Enable.
Yeah, enable. repeat like 1,000 or 10,000 times.
Okay.
Yeah, you can.
It's selecting policy LAN to WAN only.
Yeah, it was earlier log. You can
Yes. Wait.
you can initiate a 1 lakh ping response.
Okay. I think it is taking time to show the results over here, the logs.
Let's refresh the firewall page.
Yes, it is.
Yeah. Instead of refreshing the log page, can you refresh the firewall, entire firewall page?
Yes.
Yeah.
Okay. Yes, this is using policy 1, LAN to WAN. Let's go to policy. Let's select 29 and let's see what happens. It's not taking our first policy. That's why it's happening.
Destination should be all.
Destination should be
All.
okay. Everything is enabled now. Let's ping. Yes. As you can see over here, it is taking our port 3 FortiGate's exit interface, right? You can see over here. Before it was taking before it was taking the destination port 10.1.1.1. Yes.
Can you just save the NAT and can you check?
What? Can you come again? Your voice is breaking.
In the policy, can you disable the NAT? Then can you check again?
Yes.
Check this one.
Yes.
Yeah.
Yes. For sure. I've disabled it. Okay. Also refreshed it. I've pinged. Here you can see.
Yeah, you can see that. Now streaming is a local LAN IP address. Yeah.
Okay.
Yeah.
And here it was taking 4.2.2.1. Okay, guys. So we will stop over here. We will start tomorrow our application control practical. Okay. Any question, guys? Have a nice day. Okay. We'll stop over here. Thank you.
Can we have any DNAT policy or SNAT policy tomorrow?
Which one?
DNAT policy and
Yes, we will do it tomorrow. We will do it.
Yeah. Yeah, thank
Okay,
you.
we will do it.
Yeah,
DNet, we will do it tomorrow.
yeah, thank you.
Okay, welcome. Bye bye.
Wish all the nice goodbye.
Yes. Can you say again? Your voice is breaking.
I wish everyone a nice day. Bye.
Thank you.
That's what I
Okay,
want to
okay.
say.
Okay, thank you. Thank you.
Okay.